So next is also university problem. Question paper problem is also important. Find the equivalent resistance at terminal A and B using star to delta transformation method. So you can consider any method. Okay. So we can by looking at this we can see that there are three delta networks. This is one delta, this is another delta, this is another delta. So we can convert it into star here. Here also I can convert it into star. Here also I can convert it into star. Since all resistance are equal, equivalent resistance is 30 into 30, this value. Okay. Value of this one is, if you convert delta to star, this value will be product of adjacent divided by sum of all. So it is 30 into 30 divided by 30 plus 30 plus 30. Product of adjacent 30 into 30 divided by sum of all 30 plus 30 plus 30. This is 900 by 90. It is 10 ohm. So only one same values now all are connected to same thing. So I can write between these three nodes. Between these three nodes, I can write equivalent star network as this. Again, below two deltas are there. So for that, between this again 10 10 10 I can write. Again from this and this and this I can write 10 10 10. So this is also 10 ohms. This is also 10 ohms. Next, I want to find equivalent impedance between A and B only. I want to so this is 10 ohm is not at all connected to this A or B. So we can ignore this 10 ohms. Okay, we can ignore this. This we can neglect this. Well, we should not don't consider this because this is just hanging here. This end is not connected. We can neglect this because we want only between A and B. A and B we have 10 ohm resistor. After that these two are in series. Please here these two are in series and these two are also in series. So we have uh, 10. So 10 plus 10 is 20. This 10 plus 10 is 20. This 10 plus 10 is 20. Okay, this 10 plus 10 is 20. 10. This 10 and this 10 is 20. This 10 in series with this 10 is 20. This 10 and this 10 is series with 10 is 20. And this 10 ohm is just hanging because this end is not connected between A and B. We can just ignore this 10 ohms. Now this 20 and this 20 are in series. This 20 and this 20 is series. So 10 ohm. Okay, we have 10 ohm between A and B, 10 ohm. This 20 in series with 20 plus 20, that is 40. This is 20 plus 20. This 20 plus this 20. This is we are ignoring. So 10 in series with 20 parallel of 40. Again in series with this 10. This 10. Now 20 parallel 40 is, okay, 20 parallel 40 is, parallel combination of these two is 20 into 40 divided by 20 plus 40, which will give you 13.33 ohms. Now all these three are in series, 10 plus 10 plus 13.33. So final answer between A and B, final answer is 13.33. So that is the answer. And we have one more important problem. I will do after that. I will stop this. Last problem. Let me take. Determine current. This similar problem is already done. Let me take this. Okay. Find equivalent resistance between terminal A and B. Between A and B, you have to find equivalent resistance. So you can consider this as one Y network, and we can reduce this one by converting Y to delta conversion formula. Okay. So the equivalent here is, okay, here I will write 3, 5, 8, 3, 5, 8. So equivalent will be this one, between this and this is 3 plus 5, 3 plus 5 plus 3 into 5 divided by 8. So we'll get 9.87. Between this and this, 8 plus 5, 8 plus 5 plus 8 into 5 divided by this 3. You get 26.6. Between this and this, 3 plus 8 plus 3 into 8 divided by 5. You get 15.8. So next, if I convert that star to delta, I will get these values. Okay, now this full is one node. So node, these two are in parallel. This is one node. Between that node, you have this also in parallel. 26 parallel with 4 is 26 parallel with 4 is 3.47. That is 26.3 into 4 divided by 23.3 plus 4. You'll get 3.47. 15.8 parallel with 5. You'll get 3.74. Next, you will get equivalent of this 3.74 one value, 9.8 another value, and 3.4 as another value. So now we have one delta type. So still simplification is problem because we have here one delta, this side also one delta. So equivalent is now you can consider like this: 4, this is 4, this is 6. In between you have 9.78, 9.8, here 3.7, and here 3.4. So I can convert this delta to star, or I can convert this delta to star. You can take either this or this. So here you have taken down one only. So you have to write equivalent of this here. So again, for this conversion, product of adjacent divided by sum of all. Okay. This one is product of this adjacent divided by sum of all. Again, this one is product of these two divided by sum of all. So using conversion formula, calculate values R1, R2, R3. So after that, that star is that delta is converted into star like this with this. Now it is easy to simplify. These two are in series. These two are in series. And these two are again in parallel. These two series is 22.1 in series with 6 is 4 plus 2 is 6. Okay, 4 plus 2 is 6. These two are in series now. 4.2 is 6 and 6 plus 1.8 is 6 plus 2.18 is 8.18. This is 6. Again, these two are in parallel. So 6 parallel with 8.14 is 3.46. And finally, these two are in series. So add 3.46 with 0.76. You'll get 4.228. Thank you.